Amid the endless blue of the ocean, humble, spiny spheres hide within a maze of weed and stone, slowly crafting through the years a golden jewel called uni, a masterpiece of the deep, for which the culinary world pays billions to savor. And have you ever wondered how tens of thousands of tons of sea urchins are harvested and processed each year? This fascinating journey begins in cold, pristine waters, nestled deep among vibrant coral reefs and vast swaying kelp forests, or at the world's first modern sea urchin farms, where sea urchins are carefully raised by skilled fishermen until they reach full maturity, then skillfully harvested and swiftly transported to processing facilities. There, on modern production lines, guided by meticulous hands, each golden lobe of precious uni is carefully extracted, ready to become the soul of exquisite sushi or a prized delicacy on luxury tables around the world. Today, join Agriculture Insight as we take you from the icy depths of the ocean to elegant dining tables, uncovering every secret behind this spiny treasure of the sea. Among the roughly 950 recorded species of sea urchins, only 18 are harvested commercially, with major catches coming from countries such as Chile, the United States, Russia, and Canada. Within this select group, a few stand above the rest: the red sea urchin of North America and the black sea urchin of Japan, prized for their large, luscious roe, vibrant color, and rich, sweet flavor. This rarity explains why uni ranks among the most expensive seafood in the world, with prices reaching as high as $300 to $500 per kilogram, making it a prized indulgence sought after by the elite. Dominating over 80% of global consumption, Japan's sea urchin industry generates hundreds of millions of dollars each year, all from a single, one-of-a-kind ingredient, uni. For those who have never tasted it, imagine a spoonful of sea egg butter, silky and melting instantly on the tongue, leaving a rich, briny finish as alluring as soy-marinated egg yolk, with a hint of sweetness and a whisper of seaweed. Yet the story of sea urchins reaches far beyond the plate. They are the gardeners of the ocean, tending kelp forests and maintaining balance in the seafloor ecosystem. But when natural predators like sea otters vanish, or when urchins graze away every kelp spore, their populations can explode, turning lush marine landscapes into desolate urchin barrens. Even as the world's largest harvester and importer, Japan still cannot satisfy its immense domestic appetite for uni. This demand, coupled with the collapse of wild stocks, has sparked a shift toward a more sustainable future, farming sea urchins in controlled environments, from tiny drifting larvae to golden road treasures. The industrial farming process of sea urchins begins with the careful selection of healthy broodstock with well-developed gonads. By injecting a potassium chloride solution to stimulate the sea urchin's body to contract and release its gametes, and then using gravity to aid collection, technicians obtain pale yellow sperm from the males and thick white eggs from the females, ready for the next step of fertilization. Sperm and eggs are collected under sterile conditions, then combined in tanks filled with treated seawater, maintained at a stable temperature of around 15 to 20 degrees Celsius and a salinity of 32 to 35 Vs. Once fertilized, the eggs quickly begin cell division and develop into pluteus larvae, tiny, transparent creatures with delicate arms used for swimming and feeding. At this stage, they are reared separately in specialized tanks, where fresh microalgae serve as their primary food source, supporting steady growth before they transition into the adult stage. After the larval stage, the sea urchins are transferred to large tanks equipped with rocks or attachment frames to support the formation and growth of their hard shells. When they reach the size of a clenched fist after 6 to 8 months, sea urchins are grown in large sea cages or tanks, fed fresh kelp or brown seaweed, that directly determines the quality of their uni roe and market value. Over the next 4 to 8 weeks, the urchins absorb maximum nutrition, their gonads swelling to perfection, reaching the ideal state for harvest. However, larval survival rates are extremely low, making sea urchin farming challenging and limited, with success rates of only around 10%. As a result, the majority of commercial sea urchin supply still comes from wild harvesting, leading us to the next chapter, the journey of harvesting from the depths of the sea. From May to August each year, as the sea warms and daylight hours lengthen, sea urchins enter their spawning season, a time when their gonads, the rich, golden-orange roe, reach peak development, signaling a bumper harvest and the highest profits of the year. With hand diving, it may sound simple, but in reality, it's a trade that demands physical strength, skill, and finesse. Divers equip themselves with a mask, snorkel, anti-spike gloves, and, most importantly, a curved iron hook or a specialized brush. They descend to depths of 2 to 10 meters, where sea urchins cling to rocks, nestle among seaweed, or sometimes hide in crevices as if playing a game of hide-and-seek. Each lift of the hand must be precise, avoiding breaking the shell, damaging the roe inside, or getting pricked by the spines. Once collected, the urchins are placed into mesh pouches worn at the diver's side to prevent crushing, and brought back to the boat in batches. On average, a skilled diver can harvest between 100 and 300 sea urchins a day, depending on the fishing grounds and population density. The diligent divers understand that sea urchin populations have declined nearly tenfold compared to 50 years ago, so juvenile urchins must never be harvested. Selecting fully mature individuals is therefore a matter of experience, essential to maintaining ecosystem balance and ensuring the future growth of the population. Another highly effective method is bottom netting, a type of net designed differently from conventional fishing nets. As the net passes, sea urchins are swept in by the motion of the waves and the gentle pull of the vessel. This method allows for a much larger catch in a shorter time compared to hand diving, making it suitable for industrial-scale harvesting. However, its drawback is a higher damage rate. Urchins are more likely to be bumped, crushed, or mixed with seaweed and gravel, which directly affects the quality of the roe inside. Once the prized catch is secured, the fresh sea urchins are placed into special perforated plastic containers, lined with a layer of cloth or soft material to prevent breakage. They are then swiftly transported to processing plants to preserve their pristine condition before these delicate treasures can spoil. Here, the race against time begins as each one moves through a tightly controlled production line, where every step is designed to capture the very best of what they have to offer. At the start of the sea urchin processing line, containers from cold storage are moved to the raw material reception area. Each batch is emptied onto a feed conveyor, where workers perform an initial inspection. Damaged, spoiled, or dead urchins are removed immediately, keeping only those that are intact, with firm shells and meeting size standards. This meticulous attention at the intake stage is essential to ensuring the quality of the uni roe inside. Once they pass the initial inspection, sea urchins are moved to the processing area, where the most crucial step takes place, splitting the shells. Workers use a specialized splitting tool with a sharp curved blade and a smart lever mechanism, achieving an average speed of 80 to 100 urchins per hour. By positioning the blade precisely along the seam between the two shell halves and applying a gentle twist, the urchin is neatly split open to reveal the edible treasure inside. At this moment, glistening golden orange lobes, the gonads, known as uni, are exposed in a light briny fluid. Although sea urchin spines are not venomous like those of lionfish, nor do they contain the potent neurotoxin tetrodotoxin found in pufferfish, workers still wear gloves to protect their hands from punctures and scratches, reduce the risk of infection, and maintain hygiene during handling. Splitting the shell is only half the journey, for the roe of the sea urchin, known as uni, is as smooth as cream, fragile, and extremely sensitive to any physical contact, requiring the extraction process to be carried out with absolute precision and care. As soon as the shell is opened, workers use a fine metal spoon or a rounded-edge medical-grade plastic spoon to minimize tearing the delicate lobes. First, they gently remove the thin membrane and any shell fragments clinging to the roe, then skillfully slide the spoon underneath each unilobe, typically 5 arranged in a star pattern, lifting them out intact. Just one overly forceful or misaligned movement can break a lobe, greatly reducing its market value. Immediately after removal, the lobes are transferred to the manual cleaning station. Here, workers use tweezers or the tip of a small spoon to pick away any remaining strands of seaweed, connective tissue, or tiny debris. Some facilities also lightly rinse the uni with filtered seawater, both to remove impurities and to preserve its natural flavor. Once cleaned, the uni is placed in temporary holding trays and gently immersed in a diluted alum solution for 2 to 5 minutes, or in some cases up to 40 minutes depending on the roe's natural firmness. This step helps lock in the shape, enhance firmness, preserve the golden hue, and stabilize the distinctive taste, from its rich briny creaminess to a subtle sweet finish, meeting premium export standards. After soaking, the uni is drained and prepared for grading and packing, ready to leave the factory and grace the tables of fine dining establishments around the world. After processing, each piece of roe is carefully arranged by hand into specialized plastic trays or premium wooden boxes, depending on market requirements. This step demands both an eye for aesthetics and skilled precision. The roe must be placed in its most visually appealing orientation, kept intact without any damage, and each box must display uniformity in color and size. The finished boxes of uni, priced at around $100 to $500 depending on grade and origin, are sealed, rapidly chilled, and moved to the final inspection area before being placed in deep cold storage, ready to make their way to high-end sushi restaurants or the most demanding export markets. One of the most common mistakes restaurants make when receiving uni is not using it immediately, instead storing it at overly low temperatures or allowing it to come into direct contact with ice, altering its flavor, stripping away its natural sweet creaminess, and compromising its delicate, smooth texture. From the depths of the sea to the finest dining tables, uni, ranging from the prized ingredient in premium Japanese sushi to a costly delicacy on international gourmet menus, carries the story of a fragile treasure that holds the full essence of the ocean. If Japan is the mackerel processing factory of the world, responsible for about 25% of global processed mackerel output, equipped with modern production lines and a wide range of exports across 5 continents, then the United States is the consumption giant, spending billions of dollars each year to import mackerel for a market that demands high standards in quality, flavor, and nutrition. Mackerel isn't just a fast swimmer, it's a finely tuned predator of the sea. When schools of prey like sardines or shrimp enter its strike zone, mackerel swiftly join forces, spiraling into a vortex that devours everything in its path. But would you ever guess that the rich, flavorful slice of mackerel on your plate might be hiding a reservoir of mercury? Deep within that savory flesh lies the consequence of a long chain of bioaccumulation passed on from one tiny prey to the next. Eat it too often, especially king mackerel, and you may silently cross the threshold of safe consumption, with no symptoms, no warning signs. Yet, despite the warnings, the journey of bringing mackerel from the deep sea to the dinner table shows no signs of slowing down. Humans continue to pursue this high-speed fish across shifting currents and the last pockets of cold water in an ever-warming ocean, fueling a year-round global hunt. And every journey has a beginning. Join me as we set sail for the Atlantic, where specialized fishing fleets power through the waves, launching an epic chase called mackerel. From May to October, the ocean enters its golden season. Shifting currents push young sardines, shrimp, and squid toward the surface, drawing in the shimmering silhouettes of mackerel, the speed hunters of the deep. In this modern hunt, no method is more effective or spectacular than the purse seine. A massive net, hundreds of meters long, dropped into the water to form a tightening arc, a near-invisible trap in the open sea. Speed is critical. The faster the net is cinched, the slimmer the chance of escape. As the final line pulls tight like a steel noose, tens of tons of glittering mackerel are captured in a writhing mass of silver beneath foaming waters. Giant cranes roar to life, lifting heavy hauls one after another into refrigerated holds kept near -20°C to lock in freshness. In less than 30 minutes, a single haul can bring in over 200 tons, an amount that once took an entire coastal village weeks to gather. It's not just a triumph of technology, but a relentless contest between humankind and the sea. But mackerel don't always gather in dense schools. When they scatter, dive deep, or swim to remote offshore waters, fishermen must change their strategy. Instead of chasing the crowd, they patiently wait for individual fish, using the longline method, an art that demands precision and persistence. Across the vast ocean surface, a main line stretching for dozens of kilometers is deployed, carrying thousands of dangling hooks, like invisible traps suspended in the deep. The bait is fresh squid, sardines, or shrimp, irresistible treats that trigger the mackerel's hunting instincts. When a fish bites, each glistening silver body is carefully hauled in, unhooked, and placed directly into chilled storage. No bruises, no scratches, preserving its ocean-fresh quality as if it had just left the sea. As soon as the boats dock, a portion of the mackerel is unloaded at the wholesale fish market, where lively auctions begin before dawn breaks through the mist. The rest heads straight to processing factories, flowing through a network of chilled pipelines running beneath the port like its very bloodstream. At the factory, mackerel are guided into an automated sorting system using stainless steel chutes. As the fish slide down, smaller ones fall through the gaps between the rails and are redirected to a separate processing line, primarily for canning. Larger fish remain on top and continue to subsequent stages, such as filleting, marinating, or being frozen whole for export. This system enables preliminary size-based sorting right from the intake, optimizing the production process, reducing the load on later stages, and improving overall processing efficiency. Right from the initial stage, the mackerel pre-processing line demonstrates near-perfect precision. While traditional manual methods of decapitation often result in millimeter-level errors, enough to tear the skin, lose valuable meat, and reduce product value, here, each mackerel is neatly placed into a shaped mold and precisely aligned using laser guidance with an error margin of less than 0.5 millimeters. This allows the blade to cut exactly at the junction between the head and body, producing a clean, sharp separation as if machine molded. The entire process operates at a speed of several hundred fish per minute, enabling the plant to handle tens of tons per shift while maintaining exceptional consistency and precision. Next, the fish body is immediately transferred to an automatic filleting system, where blades are programmed to optimize meat yield. No excess, no waste. For specimens with a fat content exceeding 20%, the system automatically divides them into 3 proportionate portions, maintaining both structure and richness, something nearly impossible to achieve by hand. Importantly, none of the removed parts, heads, guts, or backbones, are discarded. Instead, they are repurposed into raw material for aquaculture feed, creating a closed-loop system where no part of the mackerel goes to waste. Although mackerel is not known for having many fine bones, processing plants still carry out an additional bone removal step after filleting to ensure top quality. In many facilities, this task is still done manually under intense white lighting. The fillets are placed on chilled stainless steel tables, where workers use specialized steel tweezers to carefully extract even the smallest bones, as leaving just one could result in the entire batch being rejected in strict markets like Japan or the EU. However, in modern factories, this step has been replaced by dedicated pin bone removal machines. The fish meat is passed through mechanical rollers that apply just the right amount of pressure, enough to dislodge the bones without damaging the flesh. After bone removal, the mackerel fillets are given a final rinse, neatly arranged, and moved to the light salting stage, a key step to stabilize the flesh structure and extend shelf life. First, the fillets pass through an artificial cold rain system, a chilled water spray that provides preliminary rinsing, removes surface protein residues, and cools the fillets before salting. Next, a low-concentration brine spray, 2–3%, is applied. This salt layer isn't meant to make the fillets noticeably salty, but is just enough to firm the muscle fibers, neutralize mild fishy odors, stabilize flesh color, and create a natural biofilm that helps retain freshness during freezing. Each fillet is then precisely placed onto stainless steel trays, with spacing calculated down to the millimeter to ensure even cold air circulation. This arrangement prevents sticking, warping, or deformation during freezing. Finally, the trays are transferred into a blast freezer, where the temperature drops rapidly to -35 to 40 degrees Celsius, combined with strong, cold airflow. Within minutes, each fillet reaches an ideal, deep frozen state, firm, evenly colored, and ready for packaging. However, not all mackerel is destined for frozen packaging. A portion continues its journey to a more specialized production line, where the fillets are transformed into the famous teriyaki grilled mackerel. On the teriyaki grilling line, filleted mackerel portions are neatly arranged on stainless steel conveyor belts and slowly pass through a modern roasting chamber. Instead of using direct flames, superheated steam at around 300 degrees Celsius is circulated through the chamber, allowing the fish to cook evenly from the inside out without drying the surface. After the initial roasting, the fillets move on to an automatic teriyaki sauce application system. Here, a sauce made from Japanese soy sauce, mirin, sugar, and ginger extract is evenly sprayed onto both sides of the fish. Rather than marinating in advance, the sauce is applied near the end of cooking, a technique that helps it cling tightly to the surface, forming a glossy caramelized layer when the fillets return to the roasting chamber for a final round. If salted mackerel represents the traditional flavor of the sea, then canned mackerel is a modern evolution, compact, sustainable, and ready to conquer global markets. The process begins with medium to large-sized mackerel, which are cut into segments measuring 6 to 10 centimeters in length, matching the standard height of each can. A stainless steel blade is precisely positioned over the conveyor belt, lowering at regular intervals like a metronome, slicing the fish into clean, uniform sections with millimeter-level accuracy. After the pre-processing stage, fresh, fatty mackerel portions are transferred to the canning area. Depending on their size, each can hold 1 to 3 pieces, neatly arranged either vertically or horizontally to optimize space and minimize shifting during cooking. Once arranged, the cans automatically move to the liquid filling system. The filling nozzles move in a steady, rhythmic motion, dispensing a smooth, glossy stream of liquid into each can of mackerel as it moves along the conveyor belt, just enough to fully cover the fish without overflowing. Depending on the product type, this liquid may be vegetable oil, light brine, tomato sauce, or a specialty blend such as teriyaki or a thick, chocolate-colored brown sauce. Despite their different formulations, these liquids share a common purpose: to act as a natural preservative while infusing the fish with flavor during the high-pressure sterilization process, enhancing both the taste and texture of the final product. After being filled with sauce or vegetable oil, the mackerel cans move on to a critical stage: cooking and sterilization inside a large industrial retort. Inside, the temperature reaches 121 degrees Celsius, with pressure levels so high that the cans could deform if not precisely controlled. Over 45 to 60 minutes, the fish is fully cooked inside the sealed container. The flesh becomes tender, the flavor penetrates deeply, and all bacteria and spores are effectively eliminated, allowing the product to be safely preserved for long periods without the need for artificial preservatives. If China is considered the scallop processing factory of the world, responsible for over 80% of global exports, then the United States is undoubtedly the most vibrant consumer market, where scallops are hailed as the stars of the seafood table, often fetching premium prices. Unlike other mollusks that passively await their fate, scallops are rare aquatic rebels. They snap their shells to jet across the ocean floor like tiny rockets. Along the edge of their shells, nearly 200 eyes act as a biological radar system, constantly scanning for danger and triggering escape in the blink of an eye. Here's a surprising truth: scallops, the butter of the ocean that gourmets around the world adore, are often the target of elaborate food fraud. From young shark meat to molded surimi paste, countless imposters can be shaped into what looks like a flawless scallop. But no counterfeit can fool a refined palate. The texture turns mushy, the flavor is bland, and that signature sweetness and aroma are nowhere to be found. Just one bite, and any seasoned diner will know they've just been tricked out of a real taste experience. And every journey has a beginning. Join me as we travel back to the cold, pristine seas, where millions of scallops quietly begin their lives, destined one day to become the highlight of gourmet seafood feasts. The most common method of scallop farming today is the long line suspension technique. Juvenile scallops are attached to long ropes and left to float freely in the clear, open waters. At depths of around 15 meters, hundreds of scallop lines sway gently with the current, forming a vast and untouched underwater farm. For nearly a year, each scallop grows silently in the frigid ocean, absorbing nutrients carried by the currents. No filtration tanks, no metal cages, just the harshness of nature itself shaping sweet, firm, umami-rich meat, one layer at a time. Scallops aren't only suspended in open water, they're also farmed using the bottom seeding method, where juveniles are released directly onto the soft seabed. This technique requires less labor but comes with higher risks. Predators and shifting sediments can threaten the growing scallops. Each farming method has its own strengths and drawbacks, resulting in subtle differences in flavor and texture across scallop varieties. Longline harvesting marks the most rewarding moment of the entire farming cycle. As the hydraulic crane begins hoisting each rope, stretching dozens of meters from the sea, thousands of tightly clustered scallops emerge, clinging like strands of raw ocean pearls, glistening, vibrant, and rich with the taste of the sea. Each heavy, rope-laden haul is the culmination of nearly a year of growth amid waves and frigid ocean currents. If longline harvesting is a dazzling performance of living pearl strands suspended in crystal-clear waters, then bottom-seated scallop harvesting is a quiet yet spectacular act of digging gems from the mud. Specialized vessels lower metal dredges, equipped with toothed bars and wheels, to the seabed, then slowly drag them across carefully surveyed terrain. Each gentle sweep lifts the soft sediment layer, revealing scallops hidden below, clinging firmly to the ocean floor. Harvest season typically runs from November to March, when the sea reaches ideal cold temperatures that enhance the scallop's sweetness and firm texture. Each dredging operation lasts only 15 to 30 minutes to minimize impact on the delicate benthic environment. On average, a single haul yields between 500 and 700 kilograms of scallops, depending on sediment thickness and population density. It's an art form, not as forceful as king crab hunting, nor as frantic as anchovy fishing, but slow, steady, and almost meditative, like hand-harvesting rice from the depths of the sea. As soon as the dredges and long lines are hauled aboard, thousands of shimmering scallops crowd together in heavy mesh bags. But the journey doesn't end there. On deck, fishermen begin removing the scallops by hand, a process that must be swift yet delicate to avoid cracking the fragile shells. The scallops are then poured into clean seawater troughs for a quick rinse, washing away any remaining sand, silt, or debris from their journey up from the depths. Each batch is scooped out, weighed manually on site, and transferred into specialized plastic containers, clearly labeled with trip details, harvest area, and date. From the deck, these fresh scallops are lifted by crane directly onto refrigerated trucks waiting at the dock. Within hours, they're en route to processing facilities, where a state-of-the-art system begins, preparing these pearls of the sea to grace dining tables around the globe. The scallop cleaning process in factories requires far greater precision than with other mollusks. Due to their deeply ridged shells that easily trap debris, scallops are passed through a high-pressure spray system, reaching up to 5 to 6 bar, strong enough to dislodge embedded sand and silt, yet finely tuned to avoid cracking the shells or harming the live scallops. Unlike oysters or mussels with thick, robust shells, scallops are more delicate and prone to damage, making every second of water pressure a calculated balance. This stage is both a science and an art, ensuring absolute cleanliness while preserving the scallop's freshness and structural integrity. After being thoroughly cleaned, scallops move on to the shelling stage, where precision and speed must work hand in hand to preserve the delicate, sweet meat inside. This is one of the most critical manual steps, requiring human skill that surpasses even machinery. Unlike oysters or clams, which need to be briefly boiled to open, scallops have relatively weak adductor muscles. This allows workers to open them alive using specialized knives, a method that retains freshness while quickly separating the prized white adductor muscle from the viscera and membranes. In many Japanese processing plants, trained technicians can open up to 1,200 to 1,500 scallops per hour, achieving both speed and aesthetic precision. Live shelling preserves the scallop's natural flavor and intact texture, a crucial requirement for premium export markets like the US and Europe. This isn't just processing, it's the art of carving pearls inside the factory. Yet despite its elegance, the task carries risks. Hard shells, sharp blades, and slippery hands mean that even a small mistake can cause injury. That's why workers must wear full protective gear and operate with extreme care at all times. modern processing facilities, the shelling of scallops is now supported by automated machinery, easing the burden on workers while maintaining both speed and precision. Workers simply place each scallop onto a conveyor belt. The rest is handled almost entirely by the machine. A mechanical arm holds the shell firmly in place while a thin blade glides along the edge, swiftly splitting it open. The white adductor muscle, known as the scallop meat, is then neatly extracted, while the shells and viscera are separated into designated trays. On average, such a line can process between 8,000 and 10,000 scallops per hour, with an exceptionally low error rate. Compared to manual methods, this system delivers more consistent results, improved hygiene, and is perfectly suited for the stringent standards of export markets. After shelling, the ivory white scallop adductor muscles, the most prized part, move on to a final cleaning stage. A gentle high-pressure spray system, combined with aerated water baths, removes any remaining impurities such as shell fragments, membrane strands, or fine sediment. Even after careful processing, tens of thousands of scallops are inspected and meticulously rinsed every hour to ensure each piece meets an almost immaculate level of cleanliness. This step is also what elevates the product to sashimi grade, fresh and clean enough to be consumed raw immediately after thawing. In the scallop processing industry, cleanliness is more than just a standard. It's a matter of pride, of quality, and the key to preserving the highest market value on the global stage. Once cleaned and sorted, fresh scallops are packed directly into specialized plastic containers under chilled conditions. Workers, equipped with protective clothing and sterile gloves, carefully arrange each scallop to preserve its freshness and avoid damage. The containers are then sealed, labeled with traceability information, and stored at 0 to 4 degrees Celsius, ready to be delivered to restaurants, supermarkets, or processing facilities within a short time. This method is commonly used for packaging fresh scallops intended for local markets or short-distance transport. After being thoroughly cleaned and inspected, the ivory white scallop adductor muscles are fed into an automated sorting system, where each piece is evaluated based on size, color, and meat quality. Only those meeting the highest standards proceed to one of the most critical stages in the processing chain: ultra-fast freezing. In this stage, the temperature is rapidly lowered to 40 degrees Celsius within just a few minutes. This sudden freezing process locks in the scallop's original freshness, preserves its firm texture, natural flavor, and nutritional content. At the same time, it forms ultra-fine ice crystals, minimizing tissue damage and preventing moisture loss during thawing, a key requirement for sashimi-grade products. Immediately after freezing, the scallops are transferred to the sorting and packaging system. Here, each piece is automatically scanned and classified by size or weight with high precision. Qualified meats are then portioned by electronic scales, packed into vacuum-sealed pouches or trays, and labeled with full traceability information. After being removed from the shell and cleaned, the adductor muscles are briefly blanched in hot water to eliminate any odor, kill bacteria, and retain the necessary firmness. This crucial step helps the scallop meat maintain its beautiful color and structure before entering the drying process. Next, the ivory white scallop meat is either sun-dried naturally or heat-dried in a controlled environment. This process can last from several days to a week, depending on weather conditions and the thickness of the meat. During this time, moisture gradually evaporates, causing the scallop meat to shrink into cylindrical shapes, turn a golden brown color, and emit a rich, distinctive aroma typical of high-quality dried seafood. Once the ideal level of dryness is achieved, the scallops are sorted, packaged, and stored carefully. The final product retains a deep sweetness, high umami, and is a premium ingredient in dishes like porridge, soups, or gourmet seafood broths. Behind the multi-billion-dollar scallop industry lies an invisible mountain: millions of tons of discarded shells left behind after processing. In Japan alone, more than 200,000 tons of scallop shells are generated annually. Without proper treatment, they pose a serious threat to both marine and terrestrial environments. But rather than treating them as waste, the Japanese have transformed these shells into a valuable resource. Through fine grinding and high-temperature recycling technologies, scallop shells are turned into bio-based materials used to produce helmets, construction bricks, wall paint, and even calcium-rich animal feed. In regions like Hokkaido, local governments have partnered with design companies to create eco-friendly insulation materials, contributing to a green circular economy, where not only the scallop meat, but even its shell is reborn with new value. This is more than just a technological advancement. It's a testament to Japan's masterful approach to sustainable thinking. The journey of the scallop ends with tender, flavorful slices full of refinement. But this is just a small glimpse into the vast world of food. Countless fascinating stories are still waiting to be uncovered. Let's continue the journey to discover what lies ahead. With a leg span reaching up to 1.8 meters and a body weighing more than 12 kilograms, the king crab is not only worthy of being called the king of the crustacean world, but also a symbol of an entire chain of harsh value. But why do they cost thousands of dollars each? Their high price doesn't come only from the rich, firm meat craved around the world, but also from the dangers involved in harvesting them. Living at depths of 200 to 400 meters, in waters ranging from just -degrees to 4 degrees Celsius around the Bering Sea, Alaska, and the Kamchatka Peninsula in Russia, king crabs force fishermen to face brutal natural conditions, making this one of the most dangerous jobs in the world. Another core factor behind the king crab's luxury value lies in its reproductive behavior, an extraordinarily rare growth process in the natural world. After migrating from deep waters into shallower areas to reproduce around December to February, male and female king crabs mate immediately after the female molts. Each female carries between 50,000 and 500,000 eggs under her abdomen for nearly a year, yet less than 1% of them survive to adulthood. To reach market size, a king crab must take 5 to 7 years, going through more than 20 molts, each one a gamble for survival at the bottom of the icy sea. It is this complex nature that makes king crabs impossible to farm on a commercial scale, making every bite of meat worth every dollar spent. And in the dead of winter, when thousands of king crabs gather in shallow waters to find mates, humans also head out to sea, not for love, but to hunt. That very mating season becomes the fiercest hunt of all, where man, nature, and courage together create the symbol known as the red gold of the ocean. Before every king crab fishing trip, the very first step, seemingly simple but absolutely critical, is preparing and inspecting the crab pots. Two main types of traps are commonly used, with key differences. In the US, heavy square steel pots are favored for their sturdy design, built to withstand rough seas and depths of over 300 meters. Meanwhile, in Russia, many vessels use lighter round pots that are easier to stack and more suitable for shallow coastal waters. Each pot is equipped with a biodegradable escape panel and identification tag, then neatly stacked on deck, ready to be baited. The crew carefully selects fish like herring or cod, king crab's favorite meals, which must be rotten enough to attract them. Sometimes what they endure isn't seasickness, but learning to live with the overwhelming stench of rotting fish that clings to everything for weeks on end amid the icy seas. At the same time, the fishing vessels undergo thorough inspection and reinforcement, equipped with heavy-duty hydraulic winches capable of hauling up the traps from the deep. Everything must be ready to face the rough seas and the unforgiving cold. Once everything is ready, the massive fishing vessels charge through the waves into the open sea. The fishermen are no longer just seafarers. They become fearless warriors, braving snowstorms, howling winds, and waves as tall as buildings. It's a treasure hunt in the heart of the ocean, where courage, skill, and a bit of luck determine the success of the journey. The hunt officially begins once the vessel reaches the deep offshore waters, where king crabs gather in dense numbers. The timing of trap deployment is also a key to success, often carefully calculated and carried out at dawn or during low tide, when king crabs begin to move in search of food along the seafloor. Crew members work in perfect coordination to lift the massive traps, now packed with bait, and lower them into the ocean depths. Each drop is a gamble against the sea, a hopeful bet to haul in the most prized catch. Every trap is tethered to a buoy floating on the surface, allowing the crew to return and retrieve them after several hours, or sometimes days of waiting. But the ocean is never predictable. Some mornings, the traps come up overflowing with king crabs. Other times, they're disappointingly empty, forcing the crew to change course and continue the endless search across the vast, uncertain sea. After about 12 to 24 hours of waiting, the vessel returns to the drop zone to collect the first reward of their courage. At this point, breaking the ice is not only a necessary step to get the vessel running again, but also a matter of survival. Reducing weight, maintaining balance, and preventing the ship from capsizing in the freezing, open sea. Pulling up the traps is no easy task. These giant steel cages, now coated in mud and seaweed, can weigh over 540 kilograms when hoisted from the water. A hydraulic winch system is used to lift the traps onto the deck, but that's just the beginning of the crew's real workload. They must swiftly open the trap lids and dump the crabs onto sorting tables, all while waves crash relentlessly against the ship. The massive king crabs thrash wildly, and with claws sharp as knives, they can cause serious injuries if not handled with precision and care. Although the fishing season lasts only 2 to 4 weeks each year, fishermen work up to 20 hours a day, battling 80 kilometers per hour winds, 10-meter high waves, and temperatures that can drop to minus 20 degrees Celsius. Even so, the reward is well worth the risk. With revenues reaching hundreds of millions of dollars, a single season's pay can go up to $100,000. Are you ready to set sail and take on this job at least once in your life? Once the traps are hauled up and crabs are dumped onto the deck, the sorting process begins. A critical step that determines the value of the entire expedition. But not every crab qualifies. If the minimum legal size for harvesting lobsters is around 8.3 centimeters, then only mature male king crabs with a shell width of at least 16.5 centimeters meet the criteria for processing. Female crabs and undersized individuals are immediately returned to the sea, helping protect the marine population and ensure sustainable harvests in future seasons. The entire process must be carried out swiftly and accurately, as every passing second can affect the crab's quality. While the crew works tirelessly, the ship continues to sway in the rough sea, and even the slightest mistake could lead to injury or lost catch. Once selected, the qualified crabs are placed into aerated seawater tanks on board, keeping them alive and healthy all the way back to port. After days adrift in the open sea, the final haul of king crabs arrives at port, ready to be sent to modern processing facilities. Each trip can bring in several tons of crab, earning fishermen tens of thousands of dollars. But there are also times when they return empty-handed, while fuel, gear, and crew costs continue to burn through a small fortune. It's a brutal gamble at sea, where humans face off against nature, not just to make a living, but to preserve a piece of the ocean's soul. As soon as the boats dock, the king crabs are swiftly transported to the processing plant and placed into seawater tanks to maintain their freshness. Next, the crabs are transported to a processing facility for sorting, preliminary preparation, and packaging for domestic consumption or export.